This is a grade 4 Mission 5 overview. If you're using Eureka Math, this is for Zearn. If you're using Eureka Math, it's the Module 5 overview, Zearn content. The title is Equivalent Fractions. This is a high priority mission, so you need to allocate full amount of time to this. In fact, this is not a place where you try to buy or cut time. You should be cutting time from other missions so that you can spend adequate time on this, because it is one of the most important missions you teach. It's top 2 for sure. The central focus is fractions, equivalent fractions, comparing fractions, reasoning about fractions, and then fraction operations, specifically addition of fractions with like denominators. The progression starts with finding equivalent fractions with using visual representations, but also using multiplication and division. Moves to comparing fractions with unlike denominators. Now you're discovering the reason for creating equivalent fractions so that they're easily comparable, and they compare fractions in a variety of ways, and I'll give you my opinion later on what's the most important way. And then they perform operations with fractions drawing on past knowledge, so they'll use commutative property, associative property, distributive property. Like here in a mixed number, they break up 3 2/5 into 3 plus 2/5, break up 2 4/5 into 2 plus 4/5 to make that easier to add. I do not have the correct answer there. Skills that are required for success in this mission are multiplication facts. Anytime you start working with fractions, if students don't have automatic retrieval of multiplication facts, it's going to be difficult. So to create an equivalent fraction, tough if they don't have automaticity. Make sure they have a multiplication table to work with if they are still struggling with that. And then you're not going to have a lot of time in your spiral fluency times to practice multi-digit operations. So this may not be the time to do it. But if you can throw them a problem every now and again, that would be fine, or that would be great. Core fluencies, things that are already in there. Counting by unit and non-unit fractions. This is just good activity for a prerequisite activity for adding and subtracting fractions. So you can just do this on a number line. So what I mean by that is 1/3 plus 1/3, 2/3, 3/3, 4/3, 5/3, just showing composition and decomposition of fractions. The foundational goal, so what's most important here is fraction equivalence and renaming. It's important that kids can create an equivalent fraction efficiently. It's important that they know that it's equivalent, that even though the fraction looks different, it represents the same amount of whatever. So they're just simply renaming the fraction. And then addition and subtraction of fractions with like denominators, they need to be fluent with this skill. And they need to understand why the denominator doesn't change, which I'll talk more about. What doesn't go away, so the things that you're going to always have to work on moving forward, and you've been working on throughout the year, are all the multi-digit operations. They should be becoming fluent with the standard algorithm with all these operations, or whatever algorithm you've chosen for them to use. Again, area model for multiplication and division especially aren't the most fluent uses, so move them into some form of algorithm for fluency's sake, and algorithmic learning is really important to future math learning. I'm going to create a video on that soon to explain why that's the case, but no time to do it now. Focus on division as grouping, so the grouping aspect of division. I think it's really important for them to understand that so that they retain the skill. I think it's important to them retaining the skill. Division is something that just tends to not be retained well by most students, and I think this might be a reason why. So continue to remind them when they're dividing numbers, they're just putting them into groups. So 6 divided by 2 is just saying how many groups of 2 can I make from 6, and the answer is 3. So use simple problems to explain that. And then, of course, work towards fluency with the standard algorithm. That's probably going to continue through 5th grade before most students become fluent with that. All fact fluencies, always work on, and from this point on, continue to work on some fraction equivalence, which aligns with fact fluency. Special notes, so if you have struggling learners, these special notes aren't designed for you to get through it more quickly. You need to get through these lessons and develop them well. As you look through this mission, most of them are pretty important. But if you have struggling learners, here are some tips for them. They use a lot of models in the mission for decomposition of fractions. For strugglers, I would choose one and just go over it and go over it, especially if you're running out of time. If you have multiple models, a struggling learner needs more repetition, not less. So if they're continually switching to a new model, they're never going to get enough repetition with one to really learn it, even conceptually. So pick one. I could say pick one or two, but honestly, I'd say pick one. For fraction equivalence, the models are fine. They're actually really good for helping students to see why denominators don't change. But for repetitive fluency practice, they need to practice making equivalent fractions by multiplying and dividing. For fraction addition, actually, what I stated up here about the denominator staying the same applies actually here, not there, because the denominator doesn't stay the same when you create equivalent fractions. What students need to understand with fraction equivalence is that, again, that you're not changing the value of the fraction. It's the same. It represents the same amount of stuff, the same amount of material. 1/2 and 2/4 are the exact same amount. They need to understand that, and the models will help with that understanding. And with addition, the models will help them to see why the denominator doesn't change when you're adding fractions. They need to see that, but they need to practice for fluency. They need to practice the skill over and over and over to the point of memorizing. And they can easily memorize that the denominator doesn't change, but then you bring in multiplication and the denominator does change, then that's a negative disruption to their learning. So then when they start adding and subtracting again, they'll change the denominator because they did it with multiplication. That's why you really need to hammer the models for them to understand why the denominator doesn't change when you're adding and subtracting. Then it's more likely to remain fixed in long-term memory and not be disrupted. Comparing fractions using benchmarks is really an advanced skill. With strugglers, I'm not even sure I would go there. With kids who are already struggling and low, I don't think they're going to get much out of it at all, frankly. Try it if you try it and see how they do. Maybe you'll have a kid with really high levels of spatial reasoning who, for whatever reason, just understands fractions even though they're lower in other math skills, which is not likely. So it is possible you'll have a kid who can cleave onto that. But in the end, nobody uses benchmark fractions to compare much. I mean, it'd be a really highly specialized skill that most people will never use. And moving forward into middle school, high school math, they won't use it. They'll compare fractions by creating equivalent fractions. That's why they need to focus on that skill a lot. And I say the go-to for comparing fractions is using common denominators. And of course, to create common denominators, you create equivalent fractions. Common like numerators is a very high cognitive load skill. In fact, I struggle with this one. I can probably do it, but I'm not going to trust myself to compare a fraction by looking at common numerators. So I'm going to use equivalent fractions to create common denominators to compare. So that's your anchor. To me, all fluent practice should be using equivalent fractions to create common denominators when you compare. And that's what they're going to use to add and subtract anyway, unlike is common denominators, not common numerators. So to me, the comparing numerators is almost useless, if I'm being honest.